So maybe we can start from your side, since it's a kind of question and answer. It can be just something that is personal on your side that you want me to address. Is there anything maybe in particular, sir?
So yesterday we did cosine and tan for the trigonometry.
Okay.
There's just one question
All right.
I was struggling with.
Okay. All right. It's you're saying it's a cos sine question.
Yes.
All right. Let me just open a blank screen here. Maybe if you can just do you have a question that you have there with you?
Yes, I do.
Can you give me the question?
So I have cosec alpha
Cosec alpha
equals minus 5 over 4.
minus 5 over 4. All right. Okay.
And then what we did is we took that cosec alpha and we converted it to 1 over sin alpha.
1 over sin alpha. Okay, just a sec. Let me just admit someone also. I'll be just with you shortly. Okay, I think Arnold is joining also shortly. Welcome, Arnold, to the class. Yeah, it's already in progress, but it's, as I said, Arnold, it's question and answer session. So Mr. Sprong already was just raising a question here, so you'll just join us. Are you seeing my screen, Arnold?
Yes, thank you very much.
Okay, thank you. So it's a question that is bringing in. So also if you've got something, have it ready. But I also got something for you guys as we continue. So I said from here, now we say this cosec is 1 over sine alpha, yes, is equal to minus 5 over 4. Am I right?
Yes.
Yes. Must I continue from here, or there is something that you want to ask in particular?
I just want to continue from that point down, because
yes. So must I work it down to say how did I go about that? Can I repeat that again? Is that what you're saying?
Yes.
All right. So look at this one. I was saying the easier way to remind yourself is that remember these, we call them the inverse functions. To say, if I say cosec alpha is same as saying 1 over sine alpha, and then if I say to you sine alpha is also the same as saying 1 over cosec alpha. You know, these, they work together, 1 over 1. But at the same time, in fractions, it is also allowed to, when you've got an equal sign, it's also allowed, for example, let's say I'm using this same term here. Let me show you something here. If I just come here and say to you this is over 1, now I'm allowed to flip this side and also do that. So I will have what? 1 over cosec alpha is equal to, but what you do on the left, you also do on the right. So it will be equal to what? Sine alpha over 1. But sine alpha over 1 is simple sine alpha, which is what I just wrote down here. You understand? Sine alpha is 1 over cosec. So with the same way, I can take this to the top. It will become sine alpha, then this comes down over 1, but we just ignore the 1 because it doesn't change anything. Then you can say equal to, that's when you flip the other side like that. The negative will remain as is, and then it will be equal to minus 4 over 5. It's just that you need to understand where is this negative belonging to. Now, how will you understand that? You have to remind yourself, again, as I say, let me do it here, of your trig function, SOHCAHTOA. I can continue here to say so. So I'll just stand in so, which is sin alpha is equal to opposite over hypotenuse. And I said you need to remind yourself what is opposite. It's y over what's the hypotenuse is r. Meaning, even here you will have 4 representing the y, and you'll have 5 representing the r. So it's same as saying here y over r. And I said 5 is always positive. Alright, because it's according to the triangle you're gonna have. If you are having let me just draw a triangle, simple triangle like this. If you're gonna have a triangle which has got x, y, and r like this, this will represent your y, this will represent your x, but as you do this part now is your r. The hypotenuse is always, remember that, always positive, the hypotenuse. So if it's always positive, then you can see that the negative sign belongs to what? Belongs to minus y, minus 4, which is the y part. And then from here you can then say, when you're drawing, if I'm saying sketch this thing, you can then say, okay, if I'm to sketch it here, I will have, remember, 0 here, then 90, then 180, then 270, and 360. Remember, this is also like you have got your x here hidden and you've got your y there hidden. If I say sketch, you must remember y is negative, and where is y being minus 4? It is down there. That's where we get minus 4. And then if I can sketch either here, that's where y is minus 4, or I can sketch it on the other side, which is here. That is where y is minus 4. So it depends where it can have two sections. So it can be a triangle like that, and it can be a triangle like this. But now they will restrict you. They will tell you where to draw your graph. I think in that question they said minus 180 degrees is less than x is less than 270 degrees. Am I right? I think this was the restriction we had. So now you are forced then to draw to see that it can't be here. It can only be in this side. And if it's in this side, you remember your y is minus 4, your r is equal to 5, then find the x. Find the x, and x is always the Pythagoras theorem, which says x squared plus y squared is equal to r squared. Now you know what is your y, so it's x squared, don't forget, plus bracket minus 4 squared is equal to 5 squared. Don't forget the bracket here, because if you say x squared and then you say minus 4 squared is equal to 5 squared, this will give you an error, because here if I continue this, it will be x squared plus 16 is equal to 25. But on the second one, which is an error, you will get here, let me write it in a different way, you will get x squared minus 16 squared, which is equal to 25, such that when you take 16 to the other side, it will become a plus, making everything wrong. So be careful that you put everything in a bracket, so that when it goes this side, you will then have x squared is equal to 25 minus 16. We say it is a 9. When you square root now, that's where you must be careful, because x is equal to, you say plus or minus 3. Don't just say 3, because the moment you say 3, you are saying 3 is this side, and you are saying it is going to be in this quadrant, because that's where you have got here 3 and minus 4. But they told us it's not between 270, because if I'm to write this quadrant here, it will be 270 is less than or equal to alpha is less than or equal to 360. They never gave us this side. They told us actually it's here, which means we are forced to take only the negative. Then you say therefore x is equal to minus 3. So when you've got this part to say, I know my y is equal to minus 4, I know my x is equal to minus 3, I know my r is equal to 5. You can then answer any question that they ask you, because every question that they are asking you, you can convert it now to x, y, and r. I don't know whether can I continue with the questioning, or that was the session that was giving you a bit of challenge? Or I can continue though with your question.
That was the only part that I actually really struggled with.
Okay, now look at this one. Now if I can say just a brief, let's look at something here, because some questions you find them. This paper, oh, by the way, let me introduce this, show you this paper. It was written in August 2021, so there is an exam here. It's just a full paper for your mathematics N2. If I can go on and identify a similar question like that, I think we can pick up one here. I think it's here. There it is. Let's just do something similar. It's 2 marks there. As I said, unfortunately they limit the marks, but it still makes sense. I'm not going to draw the diagram. I'm going to show you now, because it's 2 marks. It's not worth going all that route. How do you do it in shortcut? Look at this, because it's 2 marks. It says given tan theta is minus 8/15, and then 4, they give you that kind of the domain. Then they say calculate the value of sine theta. So I'm not going to give you that's justification of why I was doing what I was doing. How do you work it out in your exam? So what you do is you bring in, say, your tan theta in terms of what? Remember SOHCAHTOA, so this is our TOA. Then you divide there, it's tan theta is opposite over adjacent, right? Then you remind yourself, what is my opposite? It's y, over what's my adjacent? It's my x, right? Then you come here and say, okay, my tan theta they gave me is minus 8/15. You see, they were so clever now, because x and y are the one that x can take a positive and y can take a positive or a negative. You don't have r now, which is always positive. So this becomes a bit tricky now. What you need to do in brief is to remember your cast diagram. And your cast diagram, they told you, I'm forced now to show you this now, 090, just to show you why I will do what I'm going to do. Sorry, this is 180 here. This is 270, and this is 360. So now, what am I saying here? They are telling me is between 270 and 360, which means it's in quadrant number 4. Do you see that? And then that's where I can't have it there, I can't have it there, I can't have it there, but 270 is there and 360. So this is where my section is. And in here, as a simple line that I'm going to draw will be just a line like that, and that line will have, look at it, x here. You can see x is positive, because this direction x is positive, and look at y, this is y is negative. So you can see my x is equal to positive and my y is equal to negative. So when I come here on under tan theta is minus 8/15. Remember, 8 is my y and 15 is my x. From this justification, you can see that I can write it now and say tan theta is, now I said x is positive, it will be 8/-15. So they gave it in the center there for you to confuse you, but you can see that the negative actually belongs to what? Belongs to y. And then when we have done this, you are able now to calculate r. R is always Pythagoras theorem. R squared is equal to x squared plus y squared, which is equal to, now x is 8 squared plus y is minus 15 squared. This will always be the case. Either you're finding x, you're finding y, or you're finding r. Remember the Pythagoras or the theorem of Pythagoras. Then from there, you are able then to, because already this is r, so we're adding everything. So it will be bracket 8 squared plus bracket negative 15 squared. And then it gives me 289. But don't forget, I'm going to square root. So square root of my 289, which is my answer, is equal to 17. So r is equal to plus, okay, it was like this, just let me note this. It was r squared is equal to 289. Then I'm going to square root here, I'm going to square root here. Therefore, r is equal to 17. Now look, I never say plus or minus. Why? Because r is always positive. I'm saying plus or minus when I'm dealing with x and y. So from here, I can tell that since my r is what? Is 17, then I can answer this question. Calculate the value of sine theta. Then so, remember sine is so, which is sine theta is equal to what? Opposite over hypotenuse, which is equal to opposite is y, over hypotenuse is r. That's why you're calculating that r. So y is what? We said y is negative. Remember, there it is. That sorry. What did I say here? I said y is negative, and my y is, I made an error now here. You see what I'm doing? Remember, tan theta is y over x, opposite over adjacent. So the negative actually belong to minus 8. So here at the bottom here, that's where you've got minus 8, and then on x you've got positive 15 there. So just correct that. X is positive, as you said, y is negative, and then my tan theta is y over x, and there is my y. See, so you write now negative 8 over, and my r is 17. Then that becomes your sine theta. So it's those things that you need to be, as I say, just know the sign, which one takes the positive, which one takes the negative, and then work around knowing which quadrant are you dealing from. Like here, you saw you were dealing from quadrant number 4, and which one is positive there, which one is negative. So all those things is what they're trying to trick you on. I don't know if it makes some sense, Werner?
Yes, it does. Thank you very much.
So what you do is just revise those different ones. Also, as I will post this video, bring it on again, and it will keep on making a little bit of more sense, you know. And also in my previous videos of the classes that you guys are registered on in the Google Classroom of the Mathematics N2, the whole curriculum, there is also a section that I cover. So if you can repeat them in different areas, you can actually start to see that the consistency of this approach is always like that. Then you will get a little bit more firm in your understanding of that. All right, we're continuing. Let me check with Anno. Any question, Anno, that is you want also? Can be rotating across while we are working on this. Anything that you want me to address on your side?
Yes, actually, I was practicing on this exact exam paper.
Okay, all right.
So question 1.1.2.
1.1.2. Okay, let me just come.
Yeah.
Am I right to say this is the question you are looking at? This one?
Yes.
Yes. All right. You want us to go through and just check yourself against your approach, am I right?
Yes, I think because I applied the rules like in the textbook, but they did something different here, which I wasn't sure of.
Okay. So let me just bring it in here. You have here 2 to the power of negative 4, and then p to the power of 2, q to the power of negative 3, and then everything divided by 8, and then p to the power of negative 3, and q to the power of negative 2. All right, now it's 2 marks, and then the first thing is first, because already I don't want to rewrite this thing, I'm going to convert my 8 here, and then my 8 as an exponent of what? Of 2. So you're going to, in your calculator, you say 8 equal to shift fact, it will give you 2 to the power of 3. All right, so that is our 8. Then from there, we have to apply the rule here to say, if I'm given 1 over a to the power of m, now I want to take this m to the top. Now, because of this division, the a will become now with a negative exponent. Similarly, if I have got 1 over a to the power negative m, still I want to take it to the top. Now you interchange the sign. Now since it's negative this time, it becomes a to the power of m positive. So it's a matter of interchanging signs. So if I use that same concept here and say, all right, I've got p and q, and I want to take them to the top. I've got 2. So this 2, when it goes to the top, check the sign. It was what? It was positive. So it will become now 2 to the power of negative 4 times, still multiplies, 2 to the power negative 3 now, because it was positive at first. All right. And then p to the power of 2, I'm already bringing like terms. Now p at the bottom is negative. It will become times p to the power of positive. And then again multiplied by q to the power of negative 3, When it goes to the top, this q to the power negative 2, it will become q to the power of positive q. And then from here, you continue to apply the rule of multiplication according to laws of exponent, which says if I've got a to the power of m, I multiply by a to the power of n. Now same base says I must add the exponents. Alright, so even here you now do the same thing. You say 2 to the power of minus 4 plus minus 3 is the same as 4 minus 3 here. So I'll write it like that, minus 4 minus 3, and then p 2 plus 3, and then q minus 3 plus 2. Right? Then from here you will have 2 to the power of negative 7, p to the power of 5, and q to the power of negative 1. So that becomes to me the final answer to that. And as I keep on saying, I usually prefer to test my answer against whatever I'm given. For example, I can come here and say, what if I choose my p to be equal to 3, then my q, let it be equal to, let's say 5, just any number that comes in your mind, but be consistent with your substitution. So if I take my calculator and say, alright, let me substitute and see what I'm getting in my answer. So it will be 2 to the exponent negative 7 times p, we said p is 3 to the exponent 5, and then times q, which is 5 to the exponent negative 1. I hope I'm putting this properly. We said p is 3, yes, equal to, so you see I'm getting this numbers 243 over 640 or 0.379, any of them 243 over 640. Then I go back to this one that they gave me. Remember, my p is 3 and my q is what? My q is 5. So I take a calculator again, just trying to bring in my calculator here. It's frozen. And then let's try it here to say same thing, 2 to the power of negative 4, and then you multiply by p, we say it was 3 to the power of 2, then times q was 5 to the power of negative 3. Please tell me if I'm missing out things here. 8 times p was 3 to the power of negative 3, and then we multiply by q, which is 5 to the power of negative 2. Then we see if ever it will give us something similar. I think that's the number we got, 243,640 or 0.379. So when it does this to me now, I know is sometimes the memos might make an error, but I can argue now with the memo of the whoever made a memo to say you might have missed out one or two things, because I can actually see that my simplification here is still matching the same value as the original. So those are the things that helps. They might go further from here. Maybe they went further from here, because some they go further and then they say this to say your answer you might think is wrong while it's still correct, whereby they take this negative 7 and negative 1, they take it back, but it's not a necessary step, whereby, remember, with the same rule, when it's negative, for example, if I've got this rule whereby I'm reading it going this direction, if it's negative m, it becomes 1 over. So here you'll have p5 on top, and then over 2, 7 times q. All the negatives are going down. Then only the p that is positive remains on top. So if they did up to here, you might think you're getting a different answer, but your answer here is still 100% correct.
Okay, so that's the last step I shorted, because I worked out exactly up until the blue.
Okay.
Okay. And the last yellow one, according to the exam paper, was like the yellow piece. I was
Oh,
confused.
How did they get that? So what they usually do is not really a must, man. Usually they do it in N2-A, where they will say leave your answer in positive exponents. You see, they will say that, but if they don't express that, it's not a must. The examiners, they will mark you correct. You understand? It's N3 usually when they start emphasizing that whatever answer you get, we want to see only positive exponents. Then at that moment, the final answer becomes this one. If you leave it like that, it's more like you didn't complete it.
So with that rule, you can actually just move the negative ones but keep the positive ones on top.
Yes, with that rule, you can just focus on the negative ones. And if you can go back to the previous question here, as you saw, when we're taking them up, we're taking we're interchanging the sign to say whatever was at the bottom went to the top, interchanging sign. So even here, you are only focusing though now on the negative, because the question says we don't want to see any negative exponent. So for that, you can see -7 becomes a negative exponent. When you return it in a positive exponent, not that it's wrong, but if you want to make it positive, bring it down. Again, Q, bring it down.
Okay, no, thank you very much.
Yes, sir. Yes, sir. Thank you. Okay, we're still working on, guys. Varna, any question again? Remember, guys, this is your session today. Me, I'm not the way bringing anything. It's you guys that whatever you bring from, then I elaborate on it. So it's not really my session today. So you guys need to be bringing me what you think.
I was only really struggling on that cosec and 1/sin.
Okay.
But the rest I'm pretty comfortable with.
Oh, you're pretty comfortable. Okay, we can just be doing one of a few things here. Now, anything Anna, also on your side?
For now, I'm fine, thanks.
For now, you're fine. All right. Let's scan through this question paper, guys. Yes, you'll be scanning through, and then slowly. So, if you say stop there, please do something there. Let's work it like that, So I'll be moving. This is a full paper. First one, you need to tell me to say, please just give a hint or working on that one so that we can be doing those questions. Now, simple, we go to question 1.1 is on logs. Check 1.1.2, we just did that. There is another 1.2. These are logarithms. One is 4 marks, just check it carefully there. And the other one is 3 marks. And then it says simplify the following expression using logarithm laws. And then it says show your working. You comfortable there, guys? Or you want me to do it?
I'm fine on my side.
You're fine.
I'm also good.
You're also good. Okay, next 1.3, and then solve for x in the following, and then you come back to this one again. It's 2 marks. These are exponential equations, and the first one is an exponential equation, and the other one is a logarithm. 1.3.2, making sense?
Yes, I'm still fine. Yes.
You're still fine. Anu?
Yeah, I'm also good.
It's also good. Alright. Thank you, guys. And there is 2.1 fractions. They always bring you these two types of fractions. One is the addition, and the other one is division and multiplication. So here is the division multiplication, but remember the key concept on all these is factorization. Alright, so factorization plays a role in all the questions that we're going to do. Now 2.1.1, you guys fine? Or we do it?
Maybe we can do it.
I'm good.
Okay, I know you were saying maybe I can work on it a bit.
Yes, please.
Alright, look at this one here. If we are to look at this guy here, factorization, you look at, let's look at the top one here. If I'm to factorize, I've got 3x squared minus 2xy minus y squared. I need to factorize this, and when we say you factorizing this part, I keep on saying take the first and the last, you need to multiply them together, and then when you multiply them, they will give you is 3 times 1, not just 1, -1. That product there is minus 3 and then x squared and then y squared, right? And then the sum, which is the center number here, is, I usually say S for sum is -2xy, right? Then when you're looking for the factors, it's the factors of the product, meaning two numbers you multiply to get 3 is 1 and 3. There is no other number. But now This sum is your decider. This is your decider, whereby when you add those two numbers, they must give you -2. So if I say 1 plus 3, I get a 4. But if I say 1 plus -3, I get a -2. So you can rewrite that to become 3x squared. This is the best way I prefer to factorize. Now, where there is this 1, this -2 now it's plus. Remember, 1 is positive. It's plus 1xy minus 3xy. This is the one that is representing that -2xy. This is -2xy. This one. So now why am I doing it? I'm changing it from 3 terms into 4 terms, whereby I can now factorize by grouping. Then from there, it's minus 1xy, minus y squared actually. It wasn't 1y squared, I just added that. Then I look at the first two, factorize what's common, it's x. And then it's 3x plus y. And then negative 3xy, negative y, negative is positive, but it's y this time. And then you interchange the signs every time you take out a negative. It's positive 3x and then plus y. You see? Then your factorized now is 3x plus y, and outside the brackets is x minus y. So these are the kind of factorization that they will be trying to bring. They were trying to bring that to you. So we can hold this guy here to say 3x plus y, the other one, and the other one was x minus y. So we leave it as x minus y. Then we do the same thing to this one here. Let me take this off now. We look at the same one that is at the bottom here. It requires similar part, which is 2x squared plus xy minus 3y squared. So all these they will be giving you because there is a relationship in between. Now look at this. Again, take that and multiply with that. When you multiply 2 times minus 3, the sign is very important, guys. So the product there is minus 6. Don't worry with the x squared, y squared. You can actually leave it as minus 6 like that. And then the sum is what? If you see xy, it means there is a hidden 1 there. It's just 1. Then the factors are the factors of here of minus 6, of 6. Don't worry with the signs yet. So factors of 6 is 1 times 6. It's 2 times 3. Now, factors of the product is not a problem, but the one that decides everything is your sum. The sum will tell you when you add those two numbers, you must get 1, which is positive 1. So you can see that 1 and 6 will never give me a 1 when I add them. But here, I can. Now, since it's positive 1, it means 3 must be positive, 2 must be negative. Minus 2 plus 3, when I add them, I'll get a 1. Then you rewrite that part again, 2x squared. Now, where there is 1xy, now you write minus 2, but xy. Maintain this, the variables. And then plus 3, now it's xy. Then minus 3y squared. You just change that center. That's the one that you make it from 1 to 2, so that you can start grouping. Doesn't matter. You can start by 3. It can be 2x squared plus 3xy. It's still the same. It will come out as the same answer. When you group there, you've got 2x. So 2x into that, you get x minus 2x there will give you minus y. And then here, since this is negative there and we've got a negative, so we take out a positive, that won't change the signs. So positive 3y, and then what do I have? There it will be 3y, it will be x minus y. So you can see the answer there, it's x minus y, and then outside the bracket it's 2x plus 3y. So that's what I'm going to write here, x minus y, 2x plus 3y. It's over x minus y and 2x plus 3y. So already see things are cancelling. Some of them, of course, they're not cancelling. So that is that part that they are bringing into you there to factorize. Then let's do the, I think the last one, the other one will be simpler. Let's look at this one at the bottom here. Similarly, 2x squared minus 3xy minus 9y squared. Do the same thing. Take that, I multiply. My product now is 2 times negative 9. Please see that negative. Don't say 2 times 9 because it will give you wrong factors. It's 2 times negative 9, which is negative 18. And then the sum is the center number. Again, don't say 3, but you can see that it's a negative before 3. That negative belongs to that 3. The proper interpretation of the signs is where you will get the right answer. Then from there, factors of your what? Of your 18, which is 1 times 18. Start from 1, then go to 2. 2 into 18 is 9. 2 times 9. Go into 3. How many times that 3 go into 18? It's 6. 4 won't do, 5 won't do, 6. The moment I say 6 times 3, you see I'm repeating the same factor. So you can leave it out. That's the end. But your decider, guys, is your sum. You need to add those numbers to get minus 3. So how can I get minus 3? Even if I add here, I'll never get a 3. Even if I add 2 and 9, it won't give me a 3. But look at this one. 3 and 6 will give me a 3. But not just a positive 3, and negative 3. Meaning, let my 6 be negative, so that when I say 3 plus minus 6, I'll get a negative 3. I see that. Then from there, even if I multiply 3 times negative 6, I get negative 18. See, it meets both conditions. Then I can come in and from there, let me take it from top, work it up to say this is same as 2x squared. Now, you see, it's 3 is positive, so I will say, okay, someone will say, do you have to always take that 3? No, I can start with minus 6. It will be minus 6, but don't forget it's xy. And then 3 is positive, is plus 3 xy. Don't forget the xy. And then it's minus 9y squared. Then take your first 2, which is 2x. And then from there, 2x, you've got x minus 2 into 6 is 3y. And then again here, I've got plus 3y. And then what do I have? Plus 3y. It will be x minus 3 into 9 is 3y. It must always match. These must always match. So you have got x minus 3y. Alright. And then what do you have? You have got 2x plus 3y. I see that. So now, since you have got these, you can come back here. It was divided by. So I'll need a bit of space also here to take it a bit this side. To say it was divided by, and then I'm saying at the bottom there, it's this one, x minus 3y, 3x plus 2x plus 3y. But I don't want to write divided just to save time. I must convert it into a times. Don't forget now, when I change this to a multiplication, because you don't work with division, you now know what to do. What you do is you take here, the bottom goes to the top and the top goes to the bottom when you convert from divided to times. So which means whatever was factorizing here, it's now on top. That one, which is x minus 3y, 2x plus 3y, is now on top, which becomes x minus 3y. I think it was like that. And the other one was what? It was 2x plus 3y. 2x plus 3y. Right? And then at the bottom, this one was not difficult to factorize. You can see that when we are factorizing here, you can see it's just two items here. X, it's xy minus 3y. Y is common there. You can literally see that it will be x minus 3y. So you write it now, it's at the bottom there, which is x minus 3y. X minus 3y, but outside, what did I factorize? I think I factorized y. So that becomes that. And then it's a matter of, that's what they'll be looking for. That 5 marks, this 5 marks is 4 marks is all here. Because they're trying to give you marks for this one here. Did you factorize this well? Which is can be 1, it can be 2, it can be 3, it can be 4. You see what they're doing? Did you factorize? Did you factorize? Then the final mark is you giving us the final answer. That is you cancelling well to say. Let's look what goes 2x plus 3y. I think I saw that one there. And then x minus 3y. I saw that one there. And then x minus y. I saw that one there. And then I think everything is gone except equal to 3x plus y over y. I think that is that, you see. And in your final, guys, sometimes you might discover that you had enough time, to be working on this, and time was allowing, and you're just, instead of you leaving that room, you're tempted to say, okay, I'm done with the exam. You find that almost 30 minutes are still remaining. Go back to your answers and say, let me be testing my answers. What if, for whatever reason, just test. Yeah, that's why you choose your x, choose any answer, any value. You choose your y, choose any value, put it here, get your answer, mark it, go to the original. Please don't go to yours, go to your original. Put the same value. If they are matching, it's just that assurance that you need to say, I'm not making errors here. Because it's said to say you've factorized well, and then after factorizing well, maybe you forgot to flip things here when it's times. You maintain things as they are, but everything was fine, So at the end of the day, from 5 marks, you end up getting 2 marks. So those are the things that you need just to kind of use to your advantage, whenever you're working on that. I don't know. I know. What's up?
No, that's 100%. Thank you very much.
That's fine. And then with this one now, it's also similar, but I will say let's try, unless if you want me to do it, but also similar. Look at this. They wanted you to factorize here. You see that? They wanted you to factorize here. They wanted you to factorize here. So they are literally forcing you to know factorization. So from now, as you can see, this is 5, 10 marks. And guess what? This question again, I think this one we did it together in the class. I remember doing this one. Again, factorization. So at the end of the day, 20 marks was just based on purely, do you know that factorization? Alright. But I would say, please guys, don't just have that practice. Have that practice. So is it fine if I leave this one or I do it this one? What do you say, guys? This is 2.1.2.
I'm fine on my side. I don't know if Arno is okay with it.
Yeah, I'm fine with it.
You're fine. All right. Okay, that's fine, guys. And then just to say, just as a recap, remember this one, but go to the previous videos. At one of the day one, we did this one. So just recap, give it yourself, try to solve it, and then at the end of the day, go and check yourself against that, or just look for the memo for this one. So that was that, and then let's continue with this one. As I'm saying, it's an open discussion. You guys have to say, okay, let's look at this. There is number 3.1. Says a man deducted 3 from 5 times his age and got his mother's age. I like that. And his grandmother, and got his grandmother's age. And his grandmother is 97 years old. How old is this man? What do you say, guys? Must I do it or move on? Give me your thoughts. What do you say? Do it? Move on?
Could we do it, please?
Alright. So let's come up with, so it's 2 marks. So it's not far from that. So they're saying a man deducted 3 from 5 times his age. Look at this. What is to deduct? Is to subtract. Those are the words they're trying to catch me. Now, let's say, let the man's age, that age, from his age, let's call this age x. We don't know his age, so it can be any number. So a man deducted, meaning a man subtracted 3 from 5 times, remember you're multiplying, 5 times his age. Already it says, what is the age of the man? The man is 5 times, he separated 5x. If separated 3 from 5 times his age. So is 3, first you multiply his age is 5 times x, then from there he deducted 3. So for example, if you are 20 years old, so we are going to say a man deducted 3 from 5 times his age of 20. 5 times his age of 20. So you're going to say 5 times 20 minus 3. Are you getting that concept? So from there, they are saying, and he got his mother's age, his grandmother's age. And the grandmother is what? Is 97 years old. So from there, they're saying he got, meaning equal to 97. That's what he got. Then how old is the man? Then there is the equation that you end up solving there. So from there, you take 3 to the other side. You're going to say 5x is equal to 97 plus 3, which is 100. Then you divide by 5, you divide by 5. Coincidentally, yeah, it's 20. This is 25 into 10. This is 20 years. You get it? So a man deducted 3 from 5 times his age of 20. You know, then he got what? He got his grandmother's age. So if you come here where there is x, you say 5 times 20, which is 100 minus 3, is the grandmother's age, which is 97 years old. So it's just a matter of waiting, guys, but I keep on saying these questions. Do them, but don't spend a lot of time. For example, let's say, fair enough, out of argument's sake, you go and do 10 questions of these, and then someone went to do 10 questions of factorization. I will pride the man who did factorization because he can get 20 marks out of that than someone who's going to get 2 marks on the same time spent on trying to understand either the word problems or factorization. I don't know whether you can see me.
Yes, I understand.
Yeah, but do them. Yeah, but it's good. Look, I'm not discouraging anything. Please go ahead, do them. Just I'm saying, let it be your last. When you're done with your mathematics, maybe at the end of the day, just pull out one question, try it, then. But you'd have done the majority of the other areas. You know. All right, that was that. Then there is another one, 3.2. Given this, solve for n the equation using the quadratic formula. Guys, out of interest, I just want to show you this now. This is important. We didn't cover that concept. They are saying here, you are given this. Then they are saying solve for n the equation using the quadratic formula. So what they are saying here is not difficult. It's a matter of you reminding yourself. It's 3 marks. Remember, I said whenever you are given quadratic, you must know the general form. What is the general form? It's ax squared plus bx plus c equal to 0. So when they say I must solve for n using the quadratic, actually it's even more basic. We did this one. There it is. There is my a is 4. Actually we did this. There is my b, and then there is my c. So we are going to say x is equal to, I'm just going to go straight to substitution, but you guys must quote the quadratic formula. It's minus b, which is minus bracket minus 15. That is my b here. Then it's plus or minus. Then it's square root of b squared bracket minus 15 squared. Please, if you forget these brackets, everything will be wrong. Minus 15 minus 4. My a is 4, it's 4ac, and then my c there, you see that it was negative 47, so it's bracket negative 47. Close it, and then everything is divided by 2, and my a is 4. Anyway, that is not x now. Remember, they said solve for n, so you change that x and make it n, because that's the answer for n. It was actually not what I was thinking about this question, but this is normally when they force you to use the quadratic formula. The funny part is this word problem, you expect it to have more marks, but this quadratic formula is often having 3 marks. And then you guys, you come up with 2 answers here. You still remember the plus and the minus. Is it fine, guys?
Yes, I'm good. Thank you.
Good. All right.
That's fine.
All right. Okay. This one, it's not what I was thinking for. There are some questions they ask, but I think it's more of N3 than that. Now, given this, there is another one. Make V the subject there, and then you solve for V. How many marks there? Is 3 and 1. Do you want me to attempt that, or you guys are fine there? Making the subject.
I'm fine, confident.
Okay. Anu?
Yeah, well, I'm also good.
You also good. And then the next one is simultaneous equations. It says given this is that, solve for P and Q for marks. The simultaneous. Any? What do you think?
I'm good as well.
Okay, Anu is good. Verna is good. Anu?
Yes, I'm fine.
You're fine. All right. Thank you. And then let's go to the next question, which is question 4. And there is another one. It says this is where we call it the mensuration. It says a coffee shop intends to start selling cappuccinos in a conical shape, disposable, blah 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 blah. Given that the capacity is this, then you're given the information there. you're supposed now to calculate the questions here. How is your understanding of these questions? Do you want me to do them, or you guys are good?
I think we've done
I'm
this
good
one
on
in
my
the
side.
previous video.
Yes.
Yeah, we've done something
So we can
similar.
just revert back to that one.
Thank you. Yeah, it's similar to the formulas that you play around and everything. Okay, you're right there. And then, so which means when you see it appearing like that, one needs to be a bit sensitive to keep on checking it out, because it's a different question coming twice. And then here, let me erase this side and come back to the original of this question. There it is. This one, 4.2, is the graphs. It says determine the following, so they just gave you that, and they are answering you questions: the y-intercept, x-intercept, x of symmetry, the y-coordinate. Using the graph paper, draw this graph, 5 marks. What do you say of that?
Maybe we can do this one.
Okay, let's do that one. Now look at this. It says you are given this. So before I do it, it says determine the following. Okay, let's not focus on that 5 marks. Let's go step by step. Now the thing I like about such questions is when they say draw this question after asking you questions at the top, it means this question, guys, of understanding the drawing of this question was 5, 6, 7, 8, 9. This is 10 marks. This question, just understanding graphs. Now come back here, determine this, the y-intercept. Don't forget, when you see that word y-intercept, come then write x is equal to 0. They will ask you the other one, the x-intercept, y is equal to 0. The equation for the axis of symmetry, x is equal to minus b over 2a. You see, I'm just writing that. The y-coordinate of the turning point of the function is based on me getting that value of x and using it there. So now, let's go step by step. First one, the y-intercept. I said check this, the way they have given it. Remember, you must write it as y is equal to ax squared plus bx, is a quadratic, plus c, and they gave it to you as y is equal to minus x squared minus 5x minus 6. So when you say y-intercept, x is 0. So the moment you put 0 here, this cancels. You put 0 here, this cancels. There is the answer, which is your c. So here, the y-intercept, what do you say? Here, y is equal to minus 6, because it's the y-intercept. Are you seeing that? Then the x-intercept, we are saying y is equal to 0. Then you come here on this. Remember now, y is 0. So here, that's where the 0 becomes. So what are you doing? We are solving for x there. It's a quadratic equation, which is minus x squared minus 5x minus 6 is equal to 0. Now guys, I will say, if you are not good at factorization, please rely on the quadratic formula, because that's what is going to assist you. Remember, there is a hidden one there. So a, this is your a, this is my b, this is my c. So a is equal to minus 1, b is equal to minus 5, c is equal to minus 6. Then I do the quadratic formula where x is equal to minus b, which is minus bracket minus 5. I'm just doing the quadratic formula already from mind. Minus 5 plus or minus square root of b squared, which is minus 5 squared, minus 4. My a is negative 1, and my c is what? Is negative 6. Negative 6. Can you please someone calculate this for me? Divided by 2, and my a is what? Is negative 1. So it's a matter of solving here with the quadratic formula or factorizing. I keep on saying, if you can factorize, you can do that thing of coming up with what? With 2 brackets here like this. That's what they needed. But if you can, I prefer quadratic formula because, you know, I don't have to stress myself with factors, product, and then blah 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 blah. So what are you getting here for the x?
I'm just punching it.
For the positive, I'm getting minus 3.
Minus 3. For the other one, for the negative.
For the negative, I'm getting minus 2.
Minus 2. So okay, just you can verify that. So now there is the part. Here the answer is x is equal to minus 3 or x is equal to minus 2. Usually they give you numbers that are not difficult to solve. I'll say they are not like literally it will usually give you whole answers. Just check to verify with us and if ever you're getting something different from your side.
No, that's fine.
Okay, it's fine. All right. So now let's look at the next one. It says the equation of the axis of symmetry. As I said, you get this from the formulas. This is the formula you get. The moment they say axis of symmetry is the center part of the graph. Then it says what? It's telling you here, let me erase, to say x is equal to minus b over 2a. I'm using the same values I got from the quadratic formula. It's minus, you saw b was negative 5, so bracket negative 5, so there are two negatives, very important, that, over 2, and then a again is negative 1. So I'm still using those values I used in the quadratic formula. So you'll be using minus 5 over minus 1. Your calculator can come handy if you're confused there, but this negative and that negative neutralizes. At the end of the day, you've got minus 5 over 2. Which is equal to minus 5 over 2 is minus 2,5, because later I'm going to sketch this. So here you come and say x is equal to minus 2,5. It's much better than leaving it as a fraction, because if you sketch 5 over 2 sketching, it confuses you, but if you say 2,5, it's 2.5, So that is that one. And then you come back to the next question here. It says the y coordinate of the turning point, and I say axis of symmetry and the turning point is the same thing related, guys. When they ask you the y value, you come back to your original equation. This original equation then becomes y is equal to minus x squared minus 5x minus 6, right? But already you have the x, the axis of symmetry, where the graph is in the middle, which we said it was what? Negative 2,5. Then use that value to find the value of y. When you find that value of y, it will be like this. Let's say this graph was turning like that, and then there is the axis of symmetry. So the x is this line, but the y value is that point, hence they call it the turning point. That's where the graph is turning. Alright, hence you use that value of x that you just got. Can you please substitute for me? Which is here minus, look how I'm doing it, please just focus on how I'm going to substitute here, because the negative is what is going to affect you. So it's minus bracket minus 2,5 squared, you see that, minus 5 bracket minus 2,5 minus 6. Okay, let me show you what I usually do sometimes to avoid confusion. Look at my calculator here. What I do is I know that my x is negative 2,5. So this is what I do. I will say minus 2,5 equal to, you see, even if I press AC and I recall my previous answer, your calculator keeps the previous answer, right? So when I want to find now the value of substitution, I just come here and say that minus will be minus x squared. It's answer squared. I don't have to, sorry about that. It's minus, and then x squared becomes answer squared. You see that? My answer is already kept as negative, so I don't have to even put brackets. It's already like that. And then minus 5 answer, and then minus 6. You guys do your own. I'm not going to say equal. Do your own here with this one, and then let's compare the answers. Can you do that and tell me what you guys are getting with that? Minus bracket minus.
I'm getting 1 over 4.
1 over 4. Alright, equal to, there it is. So sometimes to avoid just from here without even substituting, they might not be worrying about, because it's 1 mark. You can just quickly say x negative 2,5 equal to, keep it as an answer, say minus answer squared minus 5 answer minus 6. It quickly gives you that. But now y is equal to 1 over 4, but this will be better if we use 0,25, I think. 1 over 4 I think is 0,25. So there it is, 0,25. Then they say use the graph paper provided. They will give you the graph paper, please. If they don't, you need to request a graph paper. That's why in the front page they'll say you need a graph paper to do this. It says draw this equation on the same system of axes indicate all intercepts with the axis. See, they need to see all that. Show us the turning point and show us the axis of symmetry with a broken line. It's 5 marks. So if we are to do that, we're going to use all these values, but let's come here and kind of have our graph paper here. Now, before that, I need to know which one is my maximum and my minimum for the y values. Look at this. I've got y being -6, so there is more negative there. And then I've got x being -2,5, -3, -2. But there is something I didn't do here. I didn't remember when I told you the steps of drawing a graph. I say number 1, this is step 1, this is step 2, this is step 3, and then the step 4, if you remember, was shape of the graph. So this question was actually taking you through the steps. I said shape. Now we said if x is positive, if it's positive x squared, don't forget it does this. Now since here you see it's negative x squared, it will do that. So those are important things to remind yourself to say, where is it facing? Is it facing up or is it facing down? We call concave up or concave down. So from here, we know that it's going to face down, and then we know that y is more negative than positive. So if I draw my graph, let me use, I think a yellow line might be better for me here. So let's say I have my line here. Now I know y is more negative, so I don't have much of positive y. Am I right? Let me see the other part of y. We had y being -6 as the y-intercept, and the turning point is what? Is 0,25 as that. So this graph is more negative, so I can have y being here like this. Have more points at the bottom. See that? So when I draw this graph, I will then have here being still the same. It's y-axis and x. So this is my y, this is my x. Why? Because I saw that there is more negative going down. Now if I look at my x, there was nothing much on the x. I can call this 1, I can call that my 2, every 2, I can do that my 3, do the same thing every 2, I've got -1, there it's -2, there it's -3. It will help me to have those 2.5. There was 2.5, 2.5. Then the y, because it's 6, 1, 2, 3, 4. I'm forced to, for my what do you call this? My screen here can only limit me, so it will be here 1, 2, 3, 4, 5, and 6. I can't take this further, but this is negative. Don't forget that. And then positive, it's 1. I don't think there's anything above that. So once the scale is done, let's come for the coordinates. Remember, these are coordinates form. We said when x is 0, so coordinate 0, what was y? -6. This is a coordinate. So you look for 0 - 6, which is 0, x is 0, y is -6. There is a point there. And then you continue. The next one here, where the two values when y is 0. So in coordinate form, it will be -3, 0, because y is 0, and the other one is -2, 0. Actually, there is no much positive there. So I'll come to -3, 0, which is what? There. And -2, 0. Okay, there. This graph is actually more on the other side. Okay, it's fine. Let's continue with this graph. What else are we given? The symmetry line. Its x is -2,5. So we come here. See, there is 2,5 as negative 2,5. They said I must indicate by a broken line here. That is the graph will be having a center point there, right? And of course I told you that you just come here now and break this line into dotted lines. This will be my center line that will divide the graph into 2 equal parts. You see, I'm indicating all these because that's what they want to see. -3, -2, -2.5, -6. We are seeing these points. The next one is my y value. They told me the y value at that turning point. Remember, x is -2,5. So when x is -2,5, there is a coordinate here, minus 2,5. What is y? 0,25. We calculated it like that. So I'll come and look for 0,25, which you can agree with me is positive now. In the center is 0,5. So 0,25 is more like half of that half. So it's somewhere there. Right. So you need also to write that as here. It's better in coordinate form to say x is what? 2,5 and 0,25. It's much better. Or you can just come here and indicate this is 0,25. Because they will say, they will know why is he writing it. It's for the purpose of saying this is my y value at that point. Then from here, the graph, you know the shape. You can even see it. It was shaping down. There is the shape. Now you need to draw the graph. So if I'm to draw this graph, make it a bit thicker. It's a graph that you see it comes here. It's more defined this side. See, that's why I'm saying then you can have your arrow to say it continues there. But now try to have a similar line this direction, in as much as you can see. There wasn't much. Then you are forced now to try to extend your graph here. You see, just to you can see the graph was more this direction, and so from there it's more or less, but start with a pencil, avoid using a pen, or you request a new graph paper if you messed up, so that you can actually have your graph more. You see, me, I can kind of do this and tell you that I should have actually ended, my graph was supposed to be like this, because I'm picking up that it was like this. So I was supposed to have more sides here and then have something like this, meaning I needed to have more of my from here, -4, -5, -6. You see, I needed more this side, maybe -7, but I didn't need much from this side of this graph. I could even have ended here at 2 like this to fill up that graph. Then it becomes my x. But you see, you discover this as you are plotting it from the points or whatever they want to bring to you. Hence you'll be able to adjust it as it goes. So this becomes the new graph. Reading from the question, let's read again. Indicate all intercepts with the axis. To intercept is to cut. So we are indicating, there is the indication of that is an intercept. There is -2 indicated there. -3 is indicated there. And then, so far so good. And then the other one, and then the turning point. Okay, and then the turning point. Now, if there is no way of indicating the turning point except like this, you need to show us in coordinate form. Please make sure that that part is visible. That 2.5, 0,25. They will need to see it like that. Then next one, they say the turning point and the axis of symmetry with a broken line. So they indicate like the broken line. So sometimes there is that. But sometimes they go on and say the equation of the axis of symmetry with a broken line. The equation here, you come and say x is equal to -2.5. That's an equation. It's just a line that is going down. And that line is x is equal to -2.5. You see, so that is that, guys. Don't know, Anna, is it making sense?
Yeah, no, this is good. I'm fine with that.
Yes, then we can continue. Draw the graph of y is equal to -2. See now, y, I told you that this line is called x is equal to -2,5. Now if they say draw on the same graph a line of y is -2, you come here, but now not on the x-axis but on the y-axis. Don't forget the y-axis are horizontal. So if you draw -2, it will be a line like this. You go to -2, there is a line. It's the opposite of the x-axis. So it's parallel to the x-axis, but it's cutting. It's cutting at y is equal to -2. So don't draw it here and say this was the line. No, this line is x is equal to -2. Why? Because it's cutting at x is equal to -2. So the line there, you need to indicate and tell us that this is y is equal to -2. See that? Then from there, then they say 2 marks. Read from the graphs drawn in question that and that. The value, if you think it's 1, that's where they trick you there. They're saying if you think there is one value, give us that one value. But if you think there is more than one, feel free, give us those two. The value or values of x for which minus 2 is equal to that. And I told you when they make this graph, remember this is graph of y, this is the graph of y. Sometimes they'll say, this is why I said f of x is equal to g of x version, where at the point of intersection, that equal sign is when the graph intersect or where the graphs cut each other. So you come here and ask yourself, where is this line cutting? You see, then that's where now, they rely on your graph sometimes to mark you. Even if you're not accurate, they can come and check. Did you say this is the line? Remember the values of x, so they want that value and they want that value. So they'll check your graph to say, because the question was read from the graph the values of x. So we know y is minus 2, but at that point, what is x? Then you come and say, it almost looked like x is here minus 1. You see, that is that. And what about this one? You can say negative 3,5, but the center there, it is negative 3, maybe 7,5. You see, that is the other value of x here. So it's just an estimate. If you had drawn maybe in a nice way, you could have maybe curved it like that. To me, that's what it looks like, to a point whereby it more like x is equal to 4. You see that? But because of my graph, and you can adjust it and play around that. So it is that. But even if you give that, they give an allowance. Your answer, they will give an allowance between a certain range whereby your answer will still be correct. So those are things that you must not really worry a lot. And they are forced to come and look. That's why they say show by a dotted line. That person, when you've drawn it accurately, you must come and check your graph and read your points on the graph. Hence, they can even mark you correctly, even if it's a little bit away from their memorandum, because, it's a sketch. It depends how you are sketching a graph. That is that part, guys, on the graphs. Any question before I erase this part? Are you guys answered? Or you need a little extra information then? It's good. Okay. Now let's move on to we're fine with that question there. There is question 5, and then look at this, guys. You're drawing the graph of 2 cos x for that range. Please draw the graph on the system of x's on the graph paper. Do we go for it? I still have my graph paper there, or you guys are fine?
That graph is just going to be like a straight graph, isn't it? Going to be
for the cos.
It's not going to have like a real shape. Like,
okay, this one now, what it's going to have is going to be like this. Remember, when you talk about cos and sine, it will be something like this, because they say start from 0. So it will be a graph. If I'm doing right, it will be things like this. Remember those graphs?
Yes.
That's what you're going to be having.
Okay, yeah.
Because cos and sine, cos and
yes.
sine are like waves. Those are waves. So it depends on what you be given. But don't forget how you do this. Okay, let's do it together. That's where you start for the shape. Because but I'm not gonna do much of it. But I'm just gonna what am I saying? Sorry about this. I'm just gonna we do together the entering of the values. Let's start from the calculator. Take your calculators, guys, and then how do we input it? We do the same thing. You say mod, that mod there, we go to number 3, that's a table. Alright, then it will give you f of x. Then you punch 2, then cos, and then it's alpha. You look for x, and my x, where is it? My x is there. Then you close. Right, then from there, equal to, then where are you starting? They are telling you start from 0. That's where you start from. So 0, you put again equal to. Where must you end? You must end at 360. So you say 360. You say equal to. Step. I said please try go for the step of 15. But sometimes 15 can be too small. The numbers are too many. Your calculator can say error. Then we'll do the other one. Let's try 15 for now. Equal to. Okay, 15 is working. But when you are now looking for the values of x and y, guys, don't do these values that are funny. Just look for numbers that are simple. For example, 0 and 2. Are you getting that? And then what do we have? Continue. 60 and 1. Okay, maybe you guys quickly give me those values just to show you something there. Let me just do this, the table. Let me just divide as much as I can. So give me your x and your y. Give me the values 0 and 2. What was the other one that you're getting?
60 and 1.
60 and 1.
90 and 0.
And 0.
120 minus 1.
Yes, minus 1.
180 minus 2.
Minus 2.
240 minus 1.
Minus 1.
270 0.
0.
301.
1.
And 362.
2. So see, that's what you'll be focusing on. And if you have to then come back to this one here, I'm just going to do it. I think there's space here. So if I'm to draw that quickly, just to out of that, I'll do this and then have, okay, let me just undo. I'll have it like this. Try to make it as long as I can, and then I'll have something like this. And then you see with that and that, so I've got 0, and then I've got my 60, I've got my 90, 60, am I right? 30, 60, from 60, it's what, 60, I think I'm just need to be careful here the way I'm splitting this. It's 0, 30, 60, 90, from here I think it's 120, am I right? 120, 150 is 180, am I right? 180, from 180 is what, 210, it's 240, from 240 is 270, it's 300, 330 is 360. I hope I was doing this right. And then from there you start having those values. It said 0 is 2, then you come here 0. Oh, there is, I'll do this as 1, I'll do that as 2. Every 2 it's negative 1. Here is negative 2. So 0 and 2, there is a point there. And the next one is what? 60 and 1. There it is, 60 and 1. The next point is 90 and 0. There it is, 90 and 0, it's there. Then the next point is 120 minus 1. 120 is minus 1. The next point is 180 minus 2. 180 is minus 2. Then the next point is 240 is minus 1. There it is, minus 1 is here. Then the next point is 270 is 0. 270 somewhere there was 0. Then the next point was 300 is 1, 360 is 2. So 300 was 1, 300 there is 1, 360 is 2. See that? Then that's your curve. I can make this a little bit thicker, so you'll be like having your curve like this. You know, then you stop there. So it will be something like that. Then you label your graph, of course. You have your y, you have your x, and then if this is your graph of f, that is that. And then from there, yeah, that is that. And then draw the graph of this. Read from the graph in question this, the value of x for which y is equal to minus 1. You come here, already don't go far. There, y is equal to minus 1. Look, it's twice. Y, when y is equal to minus 1, there is x. When y is equal to minus 1, there is x. That's why they say read from the graph the values of x. So x is what? 120 and 240. But you come here again, when y is minus 1, you can draw that line. Y is equal to minus 1. There it is. See? So I didn't draw it well, but it was supposed to be there and supposed to be there. You know, that is 120 and 240. That is that part again. Alright? And yeah. Then, oh, by the way, this one, calculate the value of this. Guys, careful. 1 mark looks simpler, but they will need a calculator now. They don't want you to stress here. But look at this, 7 cosec this. Don't forget, it's 7 bracket. Cosec is 1 over sine, please. You can't have cosec in your calculator, so you must convert it. You must remember cosec is what? Is 1 over sine 116 degrees 6 minutes. But you remember degrees and minutes, convert that. What do you convert? 6 minutes divided by 60, which is 0,1. So you can change that now. That's 6 minutes into 6,1. It's 6,1 degrees now. So it's 7 times that. It's one mark, but be careful of such, It's very important to do it the right way. Cosec, you can't have cosec. It's 1 over cos. But don't do this now to say 1 over 7 sine that. 7 is not below, 7 is on top. It must remain on top. Hence, you saw me leaving it out on the other side. I said, the way I did it, I take my 7 and then put a bracket so that when I'm doing with the calculator, I'm telling you that 7 is removed from this. 7 is not affected by cosec. That's why it's 7 1 over, because in actual fact 7 is on top here. That's what it means. It's 7 over sine whatever that we're talking about. But with the calculator, you can leave the 7 outside here and then times 1 over. It will still give you the same answer. Alright. Then this one we did it together, and yeah, then it continues. We're here, guys. There it is, 5.4. Look at this question. ABC is shown in the figure below. Then it's a right angle triangle. Calculate the value of AC, guys. AC there. Any. Okay, let's look at this one. It's that's the soccer toy in action there. AC, AB. The value of cos squared C. What do you say, guys?
I'm good on my side.
Okay.
Yeah, I'm also fine on this
You're
one.
fine on this one. Thank you. And then there is convert. Okay, this we did degrees. This okay. Convert that to degrees and minutes. Already it's 21,7. You convert that to minutes. Remember, you multiply this 70.7 times 60. Then it will become minutes. Okay, we did that part. And then a sector. What about this one? Look at this question. 6.2 says a sector has an arc length of that and the radius of this. Calculate the following: the angle subtended, the area of the sector. What do you say, guys?
I'm good on my side. Confirm.
Okay. Anu?
Well, I'm fine as well.
Fine. Okay. Then 6.3 again. A wheel with a peripheral velocity of this completed this revolutions per second. Calculate the revolutions. What do you say of 6.3?
I'm fine on my side as well with that.
Okay. Anu?
I'm good.
Good. All right. And then the other one, this now kind of wraps it up. It's on question 6.4. The length of a major segment is this of a circle. Figure 3 has a radius of this and the chord length is that. So determine the length of a major segment edge of a circle in figure that is the radius of this and the chord length of that. What do you say, guys, of this one?
Yes, we can do it.
We can do it. All right. Now look at this one. Says determine the length of a major segment of circle figure 3 that has a radius of 4 centimeters and a chord length. The moment there are keywords chord length. So what you do, you come back to your formulas. Most part of the last section is based on formulas. So you check here of the anything to deal with the chord length. It's not here. Let's try the next one. There it is. I say chord length. Segment is a segment of a circle. So chord length is equal to x, height of a segment, and the diameter. So there is the formula. D is h plus x squared over 4h. So when you do that, you're saying D is equal to is what? H plus x squared over 4h. Let me check it again if I did that right. That formula there is h plus x squared over 4h. That's D means that, let's come again. What does it mean? X squared, x is the chord length, the height of the segment is the h, and the diameter of the circle is d. So now when you come here and solve this question, you see this particular question, they are saying determine the length of a major segment, the big H of a circle in figure 3 that has a radius of that and a chord length of that. So now, since they've given you the radius, now that particular radius, remember, is 4 centimeters. So it's your duty to convert the radius into what? Into a diameter. You remind yourself to say diameter is equal to 2 times the radius, which is equal to 2 times 4. So my diameter there is 8 centimeters. That's the first part. The second part is to take this formula, D, I'm going to do it here because it needs a little bit of work, is equal to H plus X squared over 4H. Then from here, you have to input now. They told you the D we have, the X is what? 6,9. They told us chord length, also X, 6,9. So D now is 8 is equal to H plus X squared, which is 6,9 squared over 4H. Guess what? We are supposed to solve for H. Now this, whenever you are dealing with H here, H, it will become a quadratic equation. That quadratic equation will give us 2 answers, but let's do it so that you will be able to flow with that. Now, how do you find H? Going backwards, we're saying you multiply. It's up to you, but you can multiply by 4H here. But don't forget that one also, 4H, because of that plus. Or you could have taken H to the other side and then multiply. Anyway, whatever way you can do. But at the end of the day, make sure that you're distributing 4H across. And then what you're going to have, 4 times 8 is 32H, right? Let me take it a bit down. So you've got 32H is equal to 4 times H, 4H times H is 4H squared, then that is gone, and then plus, you can leave it like that, this 6,9 squared. I don't need to hurry myself in simplifying that. Then from there, see, it's easier for me to take this to join, because it will be 0 is equal to 4H squared. Now this becomes minus 32H, then plus 6,9 squared. And you see, what are we having now? We are having a quadratic equation which is similar to 0 is equal to ax squared plus bx plus c. See, then from there is identifying what is my a. You can see my a here is 4. You're comparing h squared x, a is 4, b is minus 32 then. Minus 32, and my c is equal to what? 6,9 squared. I'll always remember it as 6,9 squared. Then you put it in the quadratic formula, but you're not finding x, you're finding h. So you're going to say h is equal to minus b, which is minus, b is what? Negative 32. So bracket, negative 32. And then it's plus or minus square root of b squared, negative 32. Someone can be entering that for me. 32 squared minus 4. My a is 4. My c is 6,9 squared. Please don't forget that. 6,9 squared. Everything is inside that. Then all over 2. My a is 4. Alright, so let's do that and give me 2 values of h. You will have one value and you'll have another value. Then I'm going to interpret that for you. So just be sensitive on the signs. Minus 32. Then you'll have the positive one and the negative one.
For the positive, I've got 6.024.
24, right? Or you can say OH, yes. Give me the other one.
1.976.
1.976. So mostly you'll get 2 answers that are positive. Now the question then comes back. Look at these 2 numbers. The question was, look at the question, says determine the length of the major segment. You see, they say major segment. Then you have to conclude now. Arno gave us that he has two values. So here, that this is the major segment H. So it's saying from here to here, that is the part which says the bigger number there. You take the bigger number, 6,024. So that's your 6,024 here. So H is equal to 6,024. Then the other one is the minor segment. The other value. It's still valid. If the question was find the value of the minor segment, you don't give us the big H, you give us the smaller value, which is 1,976, which is this one, equal to 1,976. So now you're going to say therefore H is equal to, then you give us that answer. Don't leave it in the quadratic. They will penalize you last mark because you are making us guess which one is which, because they specified find the length of the major segment. If they just said find the length of the segments, maybe, but if they say major and minor segment, still you are forced to come and say here therefore major segment seg equal to, then you give us that answer there. All right, that is that the approach there. Arno, don't know whether it does make sense on your side.
That's good. It makes sense.
All right, guys. Then there is the other one, an irregular figure. This one is that formula thing. Whenever you see this one, regular figure, and then the mid-ordinate rule. What do you guys say?
I'm good with that, thank you.
All right, Arno, and the mid-ordinate.
I'm fine, thanks.
You're fine. So, yeah, guys, that wraps up in a way. Unless you guys, your time is, I'm still having time with you, but what I wanted to bring across was just to give you a holistic view of an exam for mathematics N2. We have been going through it together, but this was just a roundup, and that kind of on my side brings everything I wanted to bring to you, and I'm happy you guys seem to be, on check with most of the concepts, and of course it needs you to go further and keep on revising. It will be always encouraging to get good marks on that final exam. So yeah, I don't know, guys, talk to me. Anything else that you want on my side, as I am still available for you.
I just want to know if I want to get the N3 textbook.
Okay.
How do we go about ordering those?
All right. You are you talking about the one that I'm providing from my side?
Yeah. So I want to have it ready. So if I go to the next class after this, then there's no delay.
All right. Okay. Do me this. I'm out of stock, but I think I'll be having it from in next week. And so what you can do, just drop me an email on that. I'll be sending you the links to. I was talking to Verna to say I'll send you the link to the last two videos on email. So you saw that email 24minutes@gmail. Just drop me a link to say please confident. Just tell me if ever you are ready with your mathematics N3. So what you're going to do, man, the moment you purchase that book, you will be just like this N2. I will automatically load you to the Google Classroom for N3. You understand? So that you will, because the book already comes uploaded, it comes in support with the video, So what you'll do is you will see yourself again being called to accept the Google, to join the Google class like you did in N2. Am I right that you are in the Google Classroom, Anna?
Yes, that's
yeah,
right.
You'll get something similar because it's already come packed up with the book. So it's also a full curriculum that you'll get there. So what you can do, drop me an email, but give me a timeline between in 2 weeks time we'll be having the books, and then just like you received this one that we sent to you, we will also courier it to you to your address.
And the videos, I'm not sure if you shared any links for new videos. I'm not sure how far you are with.
No, the videos so far. Tell me, guys, you have received 3 videos. Am I right?
Yes.
Yes. So from today, I didn't share the yesterday's video and today's video. So there's an email that will come between. I think I wrote on the what call this, when I was chatting before the class began. If you can look at the chats, I just mentioned that you will be getting the videos. I will send them maximum tomorrow in your emails. You see the email that where you have been joining the class, you have been seeing the email. So I'll also send the links in that email.
Okay,
Yeah,
no,
but
perfect.
my maximum is up to tomorrow. You must be definitely having it. If you're not, it means something's wrong. So just drop an email. So all the videos for the 5 classes, then you will have the links by end of day tomorrow.
Okay, thanks.
Yes.
Conf,
Yes.
is it okay if I send you a mail from another email, because I've been getting mails from my computer's email, then sending it to my phone because we have load shedding.
Okay.
So I've been watching the videos from my phone.
Okay. So you want to give me a different email? That's what you're saying. So
Yes,
that I can load you. So that I can load you to the Google Classroom on that email.
I have it on my computer,
Okay.
but I just need the links. But I'll send you a message from my email on my computer.
Okay, alright, it's fine. Yeah, I think it'll be fine. The moment you send me an email, it's easier even to respond towards that same email. I understand what I'm saying. To say maybe you got the links, but it's in another device, and you kind of want to view them from this other side. But yeah, just feel free, do that for me, and then I will be able to assist. So. And just guys, sorry to say, the response time, apologies, it's usually I'll say give me 24 hours. If you don't see, send again a note, but within the 24-hour period I should have responded, you know. So sometimes you might discover I just sent an email, it's almost 8 hours ago is what's happening, but just give it a period of 24 hours in between, and don't worry with the funny hours where I'll be responding to you. It's usually outside the normal working time. We've discovered that I'm able to now go through the emails and everything. But if it's very pressing, you can indicate this is an urgent email, please attend to it.
Okay, 100. Thank you.
Guys. And thank you for your time. I really appreciate having you. It was fun on my side. You guys gave me, sometimes going through the lesson can be a bit heavy, but you guys have been good. Thank you.
Thank you very much.
Thank you guys.
Thank you very much.